Hello, and welcome to this webinar on how to get started with parametric design. My name is Isaac, and I work with business development here at StruSoft. And with me today, I have Marco Pellegrino, the product owner for the FEM-Design API. This webinar will be recorded, and all example files will be sent out to all participants after the webinar is finished. We love when you interact with us during the webinar, so please feel free to comment or ask any questions. You can provide your question in the GoToWebinar interface. Normally, you can find it on your right-hand side on your screen. And at the end of the webinar, there will be some extra time to address any remaining questions. So Marco will be available to answer your questions during and also after the webinar. Should there be any issues with the sound or the picture or anything like that, just write in the chat or as a question, and we will sort that out as soon as possible. But before we begin, I just want to give a very short introduction to StruSoft. We at StruSoft develop software for the building industry. We have a precast planning software called Impact, also software for energy and for structural engineers. Our flagship software is called FEM-Design, and it's a full 3D structural design software with multiple design modules for different types of materials such as steel, concrete, timber, CLT, composite, masonry, and so on. And we'll be using FEM-Design today, and we will be illustrating the API mainly for Grasshopper, but it also exists for C#. And our main objective for the software in general, but also for our API, is to have an easy to use API and also a transparent API. So the API is open source, and you can find the GitHub repository if you just search for FEM-Design on GitHub, and you can come with requests or ask questions and feedback, or just download it and make changes yourself. We also want to encourage collaboration and community. So we have a Discord, and yeah, just feel free to contact us. We love to help you out and see your projects, and yeah, help you out the best we can. So in this webinar, we will show a couple of different examples, but before I do that, I just wanted to give you just demonstrate how you can get started with the API in Grasshopper. So Grasshopper is a tool. You can find it in Rhino, and we are using Rhino 7 in this example, but I also know that they just released a new version, Rhino 8. You can get a free trial for Rhino for 90 days. Rhino isn't connected to StruSoft. It's a standalone software, but it's used mainly within our field using the Grasshopper tool within Rhino to use the visual programming interface that it provides. And to Grasshopper, we have different packages that you can use to create your script or your code. And one package is the FEM-Design API package, or the FEM-Design API toolbox, as we call it. And you can find it in Food for Rhino. If you go to Food for Rhino, you can download it here, but the easiest way to download it is to use the package manager inside of Rhino. So when you open up Rhino, here on the left-hand side, I have Rhino. On the right-hand side, I have Grasshopper. But in Rhino, you can just write package manager, open that up, and search for FEM-Design. Oops, and I clicked enter. I shouldn't have done that. Just FEM-Design, and it shows up here. And you can install the latest version of our toolbox. When you've done that, when you open up Grasshopper, you will have a tab here on the top where you can find all the different tools for the FEM-Design toolbox. Here you can see that I have some other packages as well, but we will mainly use the FEM-Design package today, and also native built-in features in Grasshopper. If you need any help to get started with this, or need like a detailed description, you can visit our documentation. So you can visit FEM-Design API-docs.onstrusoft.com. You will get all these links and so on in the follow-up email that we send to all participants with all the example files. But here you can find our documentation for the API, as well as a blog and a Discord. And we would really like to encourage you to become part of our community, and let's help each other to spread ideas, spread thoughts, and help each other out. You can always also contact our support at femdesign.com/support if you have any questions or any issues with the Grasshopper toolbox for FEM-Design as well. So we'll happy to help you out. Okay, so when you have downloaded and installed Rhino with Grasshopper and the FEM-Design package, we can get started. And Grasshopper is a visual programming interface, and there's a lot of different features there, but I think I want to highlight one thing before I begin with the practical examples, and that is how to work with data trees. So let's jump over to Grasshopper, and I will open up a file here. So before I begin with the data tree example, I can just show you a brief introduction how it works. So here I can create different types of boxes and connect them. So let's try to create a point to begin with. XYZ. So when I construct a point, I get an instant visual feedback in Rhino, so I can see what I'm doing. So let's copy this, create a new point, and for the X value instead, I will give it a value of 5. So I have my second point over there. And if I want to create a line, I just search for a line, and it wants some input here, a point A and a point B, and it will give me a line. So I connect this here and this here, and now I have a line between these 2 points, and you can see it's in Rhino over here. So you have the inputs on your left-hand side and the output of that tool or function or whatever you want to call a component on your right-hand side. And this way you build up your script, and you don't need to write any code. You can just search for a component and connect different components to create a script. So when you're doing this, you end up working with lists in different ways. So here I have a list containing of 3 different values, a number 1, number 2, and number 3. And here you can see the position in the list for the different values. So a list can be flat, or it can be a data tree. So if I combine these 2 lists here, the 1, 2, 3 with the A, B, C values, and create a data tree, you can see that the connection here will be dashed, and I will have a data tree that looks like this. It's a data tree in this case consists of 2 different lists. So you have the first list in position 0, then you have the second list in position 1 over here. So this is a data tree, and compare that to a flat list. If I instead use the merge component and merge these 2 lists, I will just merge them together in one list. And if I let's pick the number 1 index. So let's insert my data tree there, and I select the 0 value or the 0 position. That will be my first value here. I will see that I get both the first value in my first list and the first value in my second list, if that makes sense. If I do the same thing down here and I select the first, I will only get the first value. So what you can do is to flatten a list. That's pretty common. You can do that in many different ways. You can use flatten tree like this. So I will insert this here, and now it's instead flat, and it will give me the same result as below. So this is now instead have this shape. Or I can actually flatten on the output here. So I can right click and select flatten, and it will flatten the output automatically for me instead of using a component. So that's a brief crash course on how just to handle lists in the software, because I think this is one of the key, especially for newer beginner users, that you get kind of messed up in different lists and it's not in the correct format. Maybe it's not flattened, maybe it's a data tree and you're picking the wrong value. And when I'm showing the different examples, I will use these flatten tools to get everything in one list. That's a very common thing for me to do in the examples. All right, so let's jump into the first example. And in this example, I will have one model where I read the reactions from that model, and I want to create loads to apply in another model. So let's open up FEM-Design and open up the first example here. So this is the model that I want to read. It looks like this. And here I have some point supports and a line support here. And the reactions in the point support and the line support, I want to read and transfer them and create loads from the reactions. And I want to apply the loads in this model number 2. And the model looks like this. So this could be like a basement. So the models are quite small, but it's just an illustration. It can be however large you want. It's just an illustration of to make it quick when I run the analysis and so on. So 2 very simple models. So let's jump over to Grasshopper. And if you feel like it's going a little bit quickly in this demonstration, I fully understand you, especially if you're new. Just keep in mind that you will get a recording and you can follow along step by step and pause in between and so on and rewatch. So I will try to keep it pretty quickly, but still go through every step of each script. So hopefully you can follow along, and yeah, feel free to also watch the recording if you feel like it's going a little bit quickly, if you want to try it out yourself and go step by step. So in this example, we will use a deconstruct method to open up an existing model and make changes to that or read result from that model. So let's start first to initiate a contact with a FEM-Design instance. And you can do that from the group called beta over here. It's a new tool, so that's the reason why it's under still development. So it's a beta version, but it works good. So, but yeah, soon we will also have like a full version of this, which works perfectly in all situations. It works great now, but yeah, it's still under development. So that's the reason for the beta. So I will select this FEM-Design connection, and this will give me a connection to an instance, a FEM-Design instance. It will actually open up a new FEM-Design instance over here, and it's connected to this instance in Grasshopper now. So now I can open a model in this instance, and I have this connection, and I can connect this to open model function here. And I can establish many different connections to different instances and have multiple instances running at the same time. But in this example, I will just use one. I also want to read an existing file, so I will select this model read from file, and I will give a file path. You can search for path here and just right click and select one existing file, and I will select this first model and read this in here. And now it will read the file that I created manually, normally in FEM-Design, into Grasshopper, and I can make changes or adjustments here if I want to. So let's just give it a second. It's always a little bit challenging when you're showing live demos using GoToWebinar and sharing your screen and recording, because it slows down your computer quite a lot. But now it's opened, and I will just open this model in this instance. And here you can see that I'm still available to use Grasshopper. It's working in the background to open the model in FEM-Design. So now in this instance, I have opened this model here. Okay, let's continue. I want to run an analysis. So let's open up the run analysis here. And I have to define what type of analysis I want to run. So I go into calculate, you can find analysis define. And in this case, you have different types of analysis available in the software. And I will only run the load cases. So you can see that each one here has a default value of false, except for the load case and load combination, which is default value of true. So I have to set the load combination to false because I only want to run the load cases in this case. So I can just feed it in here and it will run the analysis in the background, but I can continue building my script. So now I want to read the result from the analysis. So I will go in here and select get result, and I will connect here, and I will have to select a result type. So I can go into results over here and select result type. And in this case, I want to read the point support reactions as well as the line support reactions. So line, where is it? Line support reactions. And I will feed that into this read result. So I can just drag it here, and if I hold down Shift key on the keyboard, I can add multiple inputs to one input here. So I add both these to the inputs. So now I get a data tree. So let's take a look with a panel here. So I have this data tree where first I have the point support reactions, and then I have the line support reactions. So give me a second here. I'll just, and I can also get the model here and deconstruct other options. So if I go into deconstruct, I can select model deconstruct and select drag the model in here, and I can grab all the load cases, all the different bars available in the model, and so on and so forth. But let's continue with the results only. So I will pick a branch of this data tree, and let's pick index number 0, and this will give me only my point support reactions here. So now I have my point support reactions in this because it's the first list in my data tree here. The second is the line support reactions. And I will expand or unpackage this result. And I can go into result and select my point support reactions and just drag and drop it over here. And I have to select load case name. So I know that it's dead load that I want to take a look at. And here I have my results. So I have both the support position, the reaction forces, reaction moments, identifiers, and so on. And now I can use this to create point supports from this force. So I will create a new load. I go into loads and select point load define. And I have the point where I want to place the load because the support position, I just connect it like this. I also have the force, the reaction force. I just connect it like that. I also need a load case. So let's construct a new load case. Go over here, select load case construct. And I just give a name, dead load import, something like that, to place this new load that I'm creating. Okay, and I want to do the same thing for the live load. So I just copy this over here, and instead of the dead load, I want to grab the live load case, and I want to save this new load that I created in the live load imports load case. Okay, let's take a look at the model. So I can construct a new model by going to model construct. I can add different elements. So let's add the point loads to the load and the over here as well, and also the load cases to the model like that. And now when I have the model, I can open it in a new window. So let's go to model, open. and I can just feed it into here, and it will open this new model, which contains my new point loads that I just created from the reactions from my previous model. So on the structure tab, it will be empty. But if I go into the load tabs, I will see my dead load import load case with the point loads here, and my live load imports with my point loads here. But that's only for the point load. I also want the line load. So let's create that one. Let's go back to Grasshopper, and here we have a run node. You can set this to, its default value is true, so it will run automatically when I make any changes to the script. So let's just toggle this off for now. So I won't open a new model each time I make some small adjustments, so I can continue working without a FEM-Design window plopping up all the time. So I will just set this run node to false, and I will continue to work with the next option, which is the line supports. So let's copy this one. So instead of grabbing the 0 position, I will grab the 1 position, which is the result, the line support reaction. Again, I'm getting a data tree here with 2 different results, and the result corresponds to point supports first and then line support second. So this is the 0 position, and now I'm in the first position in my data tree, and I will get the line support reactions. So I will unpack this result as well. So let's go into result and select line support reactions, feed that into here, and I will start with the dead load. Let's grab it over here, and I can see my results. So I have element ID, node ID, reaction force, reaction moment, and so on and so forth for my line support in the dead load load case. But here you can see that it doesn't exist like a position. I only have the node ID and element ID, but that's no issue. I can just grab the finite element mesh into Grasshopper by going into beta here. I can select the get FE model, and it just wants the connection. So let's grab the connection from over here into here, and now I have the finite element model over here. And I can unpack this result, going to result and getting, for example, all the nodes. And I can drag it up here, and here you can see the nodes in the model read into Grasshopper. So now I have the node ID and all the points corresponding to each node ID, and I have the node ID for my reaction support over here. So now it's just a matter of matching those together. So I will use a feature called key value search. So I will give the keys here, the thing that I want to match. So I want to match the node ID over here with the node ID from my list here. And the value should be the point, that's the V here. And I want to search for the node ID. So if I select this here, I can see selected in green over here the nodes that is corresponding to my line support in this case. So now I have the geometry where the line support is situated. And I can just create a line from this fit line. Yeah, here we have it. And I can drag and drop, and I get a line over here. So let's create a line load. So let's go into loads, select the line load define, and I have the curve over here. Start and end force. Here you can do pretty much however you want, but for me, I just want to smear the reaction force to have a constant load. So I will just take the average value. So I will search for average, and I can grab the reaction force and get the average force, and I will have that as the start and end value for my line. So it will be a constant line or uniformly distributed line load. But here you can do whatever mathematical operation you want. If you want to divide it into different lengths, or if you want to have a triangular shape, or yeah, a constant plastic distribution or whatever. And I need to place this into a load case. So let's grab the load case for the dead load imports. like that. And yeah, that's it. So let's copy this and do the same thing for the live load. So I will just grab the live load over here instead, grab the results from the live load case, and I will place this into the live load export load case, my new load. Let's add this to the loads in the model and open up the model. All right, let's see if it opens up. Here we go. Okay, so now it's loaded. I go to the load tab and I can see that I've made a mistake because I only have the line load. Let's see again. If I made, let's see, yes. And this is what I talked about in the beginning, because if we take a look at the Grasshopper script now, you can see that I have a data tree coming from my model, out of my model over here. You can see that it's a dashed line, so it will actually give me two different models. But I don't want that. I just want everything in the same model. So I can just right click on the input of the loads and flatten that input. So everything is placed inside the same model. So that was exactly what I was demonstrating in the beginning. So now I'm feeding a lot of different inputs here, and it took this as a data tree and created two different models instead of one. So let's see now when I've opened the new model, and here we have everything in the same model. So I have both the point support and the point loads and the line loads from the point supports and the line supports in my previous model. So I can take this, just save this loads, and I can go into my model where I want to paste it, and I go into edit, paste file, and I select this, where did I put it? Model maybe. I select this this file and insert it into my existing model. So now I have my models, my loads imported into this model. Okay, that was the first example. I hope you were able to follow it along. Let's continue with the second example. So let's move over to my PowerPoint again, and this time I'm going to showcase a parametric 3D truss, both how to model it in Grasshopper, how to take the geometry and create a finite FEM-Design model, and how to run an analysis and an auto design and extract some results. You can use this parametric truss to do like an optimization, like I did in my previous webinar, where I did like an Galapagos, some kind of topology optimization. But in this example, I'm just creating the geometry. But since it's a parametric 3D truss, you can use this parametric model to do pretty much whatever you want. If you want to do like a sensitivity study, or maybe a topology optimization, or something else. So, okay, let's open up a new Grasshopper file and just save this to 3D truss live. Okay, so I can just actually open up the end goal so you can see how the truss looks when I'm finished. So let's open up the finished product, and here you can see the type of truss that I want to create. So it's this 3D truss that's parametric. So it consists of 3 different lines and some trusses in between those lines. So let's go back to the blank page and start out with defining the different inputs that I want, the different parameters that I want for my truss. So I want a length. So I can just give a value and it will automatically give me a number slider where I can set the value like this. I can name this by right-clicking and just typing a name here. So let's say that this should be the length parameter of my truss. And maybe I want a height parameter and a width. Let's copy this one. And let's say that I also want like a division of the different, how many divisions I want. So if I go into here and double click, I will get some settings for this number slider. So now it's set to be integers, whole numbers, but let's say for the width and the height, I want like a floating number with a decimal, maybe with 1 decimal, and maybe the max value should be maximum 3 meters, and maybe the same for the height, like that. So now it's like, yeah, 1 point or something point something up to 3 meters. But the division should be like a whole value. Let's say that I want to have this up to 15 as maximum. Okay. So let's say that this should be my input. So let's first create a point. So you can search for XYZ and have this construct point. And let's have the first point in 0, 0, 0. That's the default value of this inputs. So I don't have to connect anything to this input. It's the default values. The next one should be like the length of the this truss. So here you can see when I move this, I move this point parametrically. And let's create a line between those 2 points. Oops, let's do it like that. I have this line that is parametric. Okay, now I want the 2 other lines to define my truss, and I can actually, the width should be like, I want this to be the middle of the truss. So I'm going to use an expression just to write a quick formula where I have this x divided by 2 just to give half the width when I'm defining my next point. So if you zoom in here, you can click the minus to remove one input here because it's only x in this. So the width should be divided by 2, and I just copy this point and this point, and I want to have this, the height should be z and the width should be y. Okay, and then I have this length over here, height should be z and width should be like this, and then a line between those 2 points like that. Okay, and then I should do the same thing, but instead of x divided by 2, I should have like minus x divided by 2 to get the other width. I think you will understand when I'm showing the geometry when I'm done. So let's copy this one and just replace that and copy that and replace this and a line between those 2 points as well. Okay, so now you can see that this is the center line and I'm going half the distance over here and half the distance over here. That's the reason why I have this 2 expression like x divided by 2 minus x divided by 2 to get the different points. Okay, so when I have this, I'm using these buttons just to tidying up the script a little bit. You can just click here to align them in different ways, and I think that's neat to keep some kind of structure in the script. So now I have my 3 main lines, and I want to divide them into something. So you can search for divide curve, and I just connect my curve and how many divisions I want. Let's see here, and now when I change this, I get different divisions. I can of course change the length and the width and the height as well. Okay, and since it's a truss, I want like a truss going from this point to here, down to here, down to up to here, down to here, and so on. So I should find the half point of my division to get a point over there, right? Should be half distance. So I will write just a quick expression again, just a formula where you have x divided by y divided by 2, and the x should be the length of the truss, and the y should be the division. So I'm dividing the length by the number of divisions divided by 2 to get the half point. And now I can search for something called divide length, and I can set a curve and what length I want to divide this curve into. So now you can see that I get half the distance. All right, so I have x is the length of the line, y is the number of divisions. That would give me 1 for each division over here, but I divided by 2 to get the half point. All right, like this. And I'm doing the same thing for the other line to divide this as well. Okay, so now I want to connect these different points to create my truss. And this division will give me a point over here as well, which aligns with this point. And I don't really want this. I only want the middle point. So that's like every other point. And I can use a tool called dispatch. And I will give the list. So here I have a list of points that I get from this division. And it will give me according to a pattern. And the default pattern is true, false. So I can create whatever pattern I want here. So let's say that I create like a true, false, false, like that. It will take every third point or whatever it is, every third index, every third element. But the default one is good enough, every other. So it will give me 2 lists, one for the true values and one for the false values. So let's just illustrate this point. So here I have, you can see in green here, every other point like this, and the B value is the other points. And that's exactly what I want. I want these B lists to connect to this lists over here. Okay, so let's create a line. And I want a starting point, this division at the bottom, and the end point, this B division. And here you can see I've started to create my truss, and it's in the truss in one direction. And you can see at the end I get an extra one, and I don't want this one. I want to remove the last point. I want to remove this point from this list, and I can use the index, the cull index it's called, to remove something from a list. And I want to remove the last point. And I can do that by writing -1 as the value. I will get that as the index, and this is the point, and connect it over there. Okay, so now I removed this last point, so it's not included in my list anymore using this function. Okay, so that looks good. I will do the same thing for the other line. So let's just copy this one and this one, and let's take this instead and connect it here. So I've done the same like this. Okay, so now I need a line going from this point down here instead, all the way. So now instead I want to remove the first point of this list. So let's copy this one. If I want to remove the first one, I just give the value 0 to remove the first element in this list. And a new line, I want it to go from the, let's see, like this maybe. Yes, that looks good. So from the B values to this points. So if you make a mistake, if you connect it the wrong way, you will get this instant feedback in the 3D view. And this is what's great about Grasshopper and Rhino. You get this instant feedback, so you can try out yourself and see what you can understand, like, okay, I'm connecting the wrong point here. I'm connecting this point, and it should be the second point, and I can find that over here at B, like this. Okay, so getting this instant visual feedback is really great when creating geometry. And I will create then the last one the same way. So let's just copy this, and I will grab this one. Okay, so now we have the truss, and now I just need the truss elements at the top here. So let's create a new line, and I connect the B no points here and the B points here, and that will give me this. Okay, starting to look like a truss. Now I should create extra trusses at the ends here. So a line from this point to this point, here to here, and here to here. And I can of course find these points just because I created them at the very beginning. So here I have the first point over here. So I can just go over there, and then the second point, let's see, here we have a second point there. I can just drag this into here, and I can create this one. So I've prepared and done this and made the script a little bit cleaner. So let's open up this. So it's exactly the same thing. I just added those trusses at the end. And also I've created a group, or I merged the different geometries, the different lines, to one group, which corresponds to the truss elements, one to the main beams, and one to all the points where I want to place supports. And here, these two lines, I want to place the line load. So I can just go merge and just create a group, or merge different geometries into a list like this. Okay, so this geometry is then fully parametric, so I can change like the length, the width, the height, and the division number. So when I have established a geometry, it's time to feed this into the FEM-Design API. So I will start out by creating some bars here, and it needs like a curve, a material, section, connectivity, and so on. So we'll start with a curve, that's the trusses, and then material and section. And I can go over to the group called materials, select material database to grab all the material databases in FEM-Design, and then select this get material by name or index. And I can grab the steel materials and just write like S355 if I want. If I want that material type, and grab it over there. And it will give me a FEM-Design material, which I can then feed into this node. So different materials like concrete have different settings for creep and so on. And that's the reason why I can't just write the name of the material. It has to have some extra information, which is stored in this database. So I'm just picking this S355 material this way. It's the same with the sections. So I load in a database. I can pick a section from the database. So let's say the steel sections. Let's just select a panel to view the sections in this database. Here you see the different sections. I can go down, maybe I want a circular section. It doesn't really matter which one I pick because I will do an auto design anyway, but let's pick like the 430. So I can just like 430, pick it like this, and feed it into the section. And I want a connectivity as well. So these are truss elements. So I want a hinge. So you can go into bars and you can find the connectivity hinge setting here. And I feed this into the connectivity. And I want to do the same thing for the main beams, but maybe I want a different section. So I will just copy this and just change to maybe another section. Let's just pick one at random. Yeah, it's a larger section, still a circular one, and feed that into the section. And maybe I don't want this to be hinged, so I remove that one. When I want to remove a connection, I can just hold Control and I get this small minus sign where I can like remove connection like that. So now I have the beam for the trusses and the main beams. And then I want the supports. So I go into supports. Let's say that I want a hinged support, point support hinged, and it just wants the points. So I have the points over here in my list. So I just grab them, feed it into here, and then maybe some loads. So I will create, as previously, a load case, actually two load cases. Let's say that I want dead load and maybe a live load case as well. And here on the type, I can select if I want, the default value is ordinary, but here I can select if I want the software to automatically calculate the dead load. So that's the same as selecting in FEM-Design under the type. So if I write dead load like that, I will get this type. So let's construct a model. I'll go into model, construct, and I'll add the different elements, my bars, my point supports, my load cases, and I need some loads as well. Actually, let's flatten this straight away, so I don't end up getting multiple models like I did in the previous example. So let's add a line load. So I go into line load define, and I want a curve, starting force, end force, and a load case. So the curve, I have these two lines that I want to apply here, and let's say a value. It should be a vector, the start force and end force. So let's search for vector, and maybe I want just minus 30 kilonewtons in Z direction. I just as a start and end force, and a load case. Let's put that into the live load case and add that to the model. So as you can see, when you get a little bit faster, I'm still pretty new to Grasshopper, to be honest. I work mainly with sales, so I'm not a developer or anything like that. But as you can see, it almost goes quicker doing it in Grasshopper than modeling in FEM-Design sometimes when you're creating loads and so on. So that's pretty neat, I think. Now I want to open up this model. So let's go for the establish a connection again. Let's see if it opens up. I have this connection here, and let's open this model. And I also want to run an analysis. So I will go into beta, select the run analysis, and I will connect it over here. And now you can see that it's done. So I can go back to FEM-Design and view my structure. You can see that I have some error here because I'm missing the main beams. So let's take a look and see if I made a simple mistake here. Yes, so I'm actually connecting the main beams to the truss group as well as the truss to the truss group, but it should be like this. These are my main beams. So let's go over there. And it will automatically reload the model when I make any changes, since the run node is set to true by default. So let's continue with the analysis. Well, actually, let's just double check that it looks good. Yeah, it looks good now. Let's go and define an analysis type. Go into calculate, analysis define. And here I can see that the combination and the load case is by default set to true. So I can just feed this into the analysis component and run the analysis in the background. No declared load combination. Oh, I forgot that one. Let's actually create a load combination as well, because I'm asking to run the load combinations, but I don't have any load combinations defined. As you can see here, I haven't connected anything to the load combinations here. So let's go back to loads, select the load combination construct, and just put a name, ULS. And here you can also define the type, but by default it's ultimate ULS, ultimate ordinary. And the load cases. So I will first feed in the dead load like that and the live load. And I have to set the gamma values also. So I can do this in a panel, I can just give 1.2, 1.5, and just right click and select multi-line data, and it will create a list for me. So now this list with the first the dead load and then the live load is paired with my factor 1.2 and 1.5. Now I can feed this into my model, and it will rerun and hopefully work now. Okay, so yes, it's processing, and let's see if it's also done in a couple of seconds. Yeah, so I can go in here and I can see that I've run the analysis. I have results over here. Let's continue to do an auto design. So let's go to the run design, and I have my connection, and I want to define the design settings and design groups as well. So let's go into calculate and design define. Here I can set the different mode, so it can be RC, steel, or timber. So let's say steel in this case. I can also set if I want to do an auto design. I want to do an auto design, and I also want to apply the changes when I rerun the calculation. And yeah, let's also define the design groups. So let's go to calculate again, and here you have design group define. And design groups are very nice because each element inside a design group will be assigned the same section. So that's very useful in this case where I have like one group for the truss and one for the main beams. So maybe I want the same section for the truss and another section for the main beams. So let's say I set a group name truss like that, and a group name beams, let's say like that. And then I just feed the structural elements into here. So here I have the truss elements, feed that into here, and there is the main beams. I feed it into there. And then I just feed this into the design components like this, and it will run the design here for me. Okay, so when I run the design, I will change the sections, and the dead load will be changed, and the stiffness of the structure will be changed. So I need to rerun the analysis to have a valid result. So I will do that afterwards here. So I will grab the run analysis again, connect my connection here, and then I actually need the analysis again. So I just grab the same analysis. And let's just extract some results the same way as the previous example. Let's go to get casecomp results, feed my connection into here, select a result type, let's say bar internal force. And yeah, here I have my result. And in the background, of course, I have my auto-designed truss, which is fully parametric. So of course, if I want to make any changes over here, I can do that in my inputs. But when working with sliders, it's always a good idea to set the run node to false, like this, make any changes and then set it to true, because when I drag in on a slider, it will have many intermediate values, and it will trigger analysis each time for each intermediate value. So that's the reason why if you want to make changes, it's very nice to keep it as false and make your changes and then run the analysis by switching this to true. All right, that concludes the second example. And to finalize the webinar, I just wanted to say that if you want to try out this by yourself, and maybe follow along step by step to create these two examples, you can do so by applying for a free trial at strusoft.com or using this QR code. I would also like to mention that we have an upcoming event in the beginning of next year, in January next year. We are releasing FEM-Design 23, our new version, which will have a lot of features for bridge engineers, plastic, concrete, which will save you a lot of reinforcement and so on. So keep an eye out for the new version and all the new features in the new version.